Okay, so let's go through some of the main differences between linear and exponential change. So linear has a slope while exponential has a growth factor, which is a constant rate of change versus a non-constant rate of change. When I graph this, linear is going to be a line, obviously linear line. Exponential will create a curve. Linear will add or subtract each time. Exponential multiplies each time. Linear can be written in the form y equals mx plus b, and exponential is y equals a times b to the x, where b is the growth factor, a is the y-intercept, and we know m is the slope and b is the y-intercept on slope-intercept form. So we're going to go through each one of these and see exactly what they mean. Let's use the example that we've been using, which is the rice on the chessboard. So in the video that you saw, we started with 1 and it doubled each time. 1 times 2, 2, times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, 64, etc. So that's what we mean by exponential multiplies each time, whereas linear adds or subtracts each time. So if we wanted to make something linear, let's say instead of doubling each time, we're just going to add 2 each time. So 1 plus 2 would be 3, plus 2 is 5, plus 2 is 7, plus 2 is 9, plus 2 is 11, plus 2 is 13, etc. So that would be linear, adding or subtracting each time. Now let's go to the next one. Does it create a line on a graph or create a curve on the graph? Let's look at those when we graph them. So for simplicity's sake, we're going to say that this right here, the first one, is block 0 because nothing's happened to it yet. So block 0 is going to start with 1 piece of rice. So at 0, we have 1. And then for linear, we're going to add 2 each time. So the next block, 2, will be 3. Next block will be 5. Next block, 7. And so on. 2 every time we go over 1. Every time we move over 1 block, we gain 2 more. So that is going to be a line. Let's try the exponential one where there's a growth factor. We're still starting at 1, but on the next block we multiplied by 2, which is less than the linear here. But on the next block we multiply by 2 again, so it's going to be 4. Still less than the linear, but multiply by 2 again on the next, and you see that we start to eventually grow a lot faster to 8. The next one we multiply by 2, we get to 16, somewhere around here. And if we make that curve, you get something that looks along the lines of that. This is a curve here, whereas the straight line, if we're just adding and subtracting, this is going to start out and then just go whoop, right on up. Okay, so we see that the linear, if you add or subtract each time, it creates a line. For exponential, if you multiply each time, it makes a curve. Let's see how those look on our equations. So we know y equals mx plus b is a line. So if we look at that and say my y-intercept is 1, we know b is the y-intercept, so 1 plus my slope is 2, rise 2 over 1, we know that because we're adding 2 each time. So that's my m. So y equals 2x plus 1. Why is it 2x plus 1? Well, that's because if we start on block 0, then x is 0. 2 times 0 is just 0. 0 plus 1 is 1. That's where we start. That's why we know that b is the y-intercept, because when x is 0, that's where we start, then we're just left with whatever b is. That's why that is your y-intercept for the linear. And then each step, each block is going to be x. If I go to the next block, block 1, then it'll be 1 times 2, which is 2, plus 1 is 3. 2 times 2 is 4 plus 1. So each time you take a step on the block, x is going to go up. You're going to add another 2. That's how that equation works. If we look at the exponential, we know that b is the growth factor, so I'm going to have y equals, if I'm multiplying by 2 each time, the growth factor will be 2. 2 to the x, and a is my y-intercept, which is 1. 1 times 2 to the x. Now, does that work? Let's look at it. If I start at 0, x is 0, then I have 1 times 2 to the 0th power. Now, what's something to the 0th power? Anything to the 0th power is 1. So 1 times 1 is 1. So we know that this a will always be the y-intercept, because if x is 0, then this is just 1, and anything times 1 is going to be itself. So whatever this number is, we're going to be multiplying by 1 when x is 0, and that's just itself. So that will always be the y-intercept. So then you have to consider, why here am I multiplying and here x is the exponent? So let's talk about that for a moment. So just like when it's linear over here, x is how many times that thing is going to happen. So when we write something, should be in blue, when we write something linear, y equals, I start with 1, and then I'm going to add 2 each time. So x is each time, because however many times we do something, that's how many times we're going to add 2. If I want to do it once, it's 1 times 2. If I want to do it twice, it's 2 times 2. If I want to do it 3 times, it's 3 times 2. This is how many 2's that I'm adding. That's linear, adding each time. It's the same concept, but with a different operation with exponentials. So when I say y equals, I start with 1, and then I'm going to multiply by 2 this many times. What does an exponent mean? That means how many times do I multiply this thing. So on a side note here, if I had something like 3 to the 4th, that means I have 4 3's that I'm multiplying together. That's 9, that's 27, and then whatever that is that I don't feel like doing right now. So when you come here, this means I'm starting with 1, and then I'm multiplying by 2 this many times, right? Because if I start out at 1, then I would be multiplying by 2 0 times, which would be 1 times 1, which is 1. If I wanted the 4th block, that would mean y equals 1 times 2 to the 4th. That means I'm multiplying by 2 4 times. So that's what I get. 1 times 2 is 2, times 2 is 4, times 2 is 8, times 2 is 16. Do I have 16 in the 4th block? 1, 2, 3, 4. Yes, I do. So this just means how many times are you doing that? So here you'd be adding 2 each time, and here you're multiplying by 2 each time. So that covers everything on here except for the terminology. The slope gives a constant rate of change. The growth factor does not give a constant rate of change. So when we look back at what we were talking about, a slope is m here. That just means I have a constant rate of change, so I'm adding the same amount each time. Whereas a growth factor, factor meaning you're multiplying, factor, that means I'm multiplying by 2 each time. So b is the growth factor because I'm saying I take what I start with, multiply it by this however many times. Whereas here I say take what I start with and add m this many times. So that's the difference between the slope and the growth factor. So those are the main differences between your linear and your exponentials. I hope it makes a little more sense now.